go to name it, you do not change anything with your first element. The second element is going to get an ending swap. So instead of ending however it normally ends, it's going to get an IDE ending, okay? So like instead of chlorine, it's going to become chloride. Oxygen is going to become oxide. We're just going to see a swap of the ending to IDE. Now, two things we're going to watch for. We're going to watch for polyatomics, and we're going to watch for transition metals. And that's what we're going to be practicing a lot today. Now, for all of this naming rule stuff to apply, we have to have an ionic compound, which means it has to be made of ions. To have an ionic compound that we looked at since the other day, you need to have metal and non-metal together, okay? So we need to see something left of the steps with something right of the steps, okay? We've got metals and non-metals both in the same compound. Now, I'm just going to write some quick examples here, but we're going to do plenty of examples, but just so you can kind of see this process happening. So we are going to have things like sodium chloride that we keep looking at, right, as an example here. Thank you. Yep. So sodium chloride. Give me a second here. I'm hoping it shows up. But we have this idea that we have sodium being the same. The second one, if we pair sodium and chlorine like we've been doing with our table salt, we should be seeing, okay, so we've got this case where we keep the first one the same and the second one is going to change, okay, to that IDE ending. Give it 1 second. I'm hoping we're live. All right, so to give you another example too, as I'm waiting for that to show up, if not, I'll write on the board if I need to, but we're trying to look at this idea of polyatomics and transition metals. So as we're looking at polyatomics and transition metals, we're going to watch for those in our naming process, but we're going to do, again, a bunch of examples that you're going to see. These examples that we're going to go through one by one, you'll see all of this in play, okay? Wait 1 quick sec here. There we go. All right, so sodium chloride is an example. Another example, just so you can see this, so you can preview kind of what we're going to be doing. If we have a transition metal, you're going to see Roman numerals today, okay? And that's what that picture at the top here is. I'm going to use again here in a second. But for example, you might see if copper is with chlorine instead, you're going to have copper with a Roman numeral after it, and then chloride changing the ending. Now, the reason that this Roman numeral is here is to tell you the charge of copper in this particular compound. Remember that with all of our transition metals, we do not have any sort of charge written above them. So this whole section from columns 3 to 12, there's no charges above them that you know of. So you need a Roman numeral to tell you what the charge is in that particular compound. So if you look up at this example page that we put in here at the top, you can see examples of like copper having a +1 charge versus a +2 charge. The reality with these transition metals is they can have more than one charge. So you use these Roman numerals in parentheses after them to show someone what the charge is for it in that particular compound right now, okay? It could have a different charge with a different compound. It could even have a different charge with the same thing. It just is capable of giving up different amounts of electrons, okay? But we know they're all metals, so you're going to see them having positive charges. It just changes on what the positive charge is at that point, okay? So that's what we're going to preview working through today, okay? All right, so let's do a bunch of examples here. So again, we're going to go through one by one. You're welcome to write these examples with me as we do them here, but we're going to practice naming them, okay? So again, first metal, or the first element, which is your metal, is going to stay the same with its name. The second one's going to get that swap to an IDE. We're just watching for polyatomics. We're watching for transition metals. So how are you going to recognize the polyatomics? If you have more than 2 elements, that's going to have a polyatomic M like that, many atoms together. So like I'm seeing 2 elements for the first one, just magnesium and oxygen. But if we skip down here, we see how CaSO4 has Ca, then S, then O. So we're getting the idea of, okay, we've got more than 2. We're going to think it's a polyatomic and use that table at the top, okay? But let's go one by one. So the first one is MgO. So we're going to name it. Mg is normal, so magnesium. That is just the name of Mg from the periodic table. And then instead of oxygen, we're changing the ending to ide, so oxide. Now, would it be a problem necessarily we do call it oxide. But if you wrote like oxygen and you just tried to get rid of the ending and put an IDE, I wouldn't take off any points because you're trying to swap that ending. Oxygen, we just swap that ending a lot earlier, make it oxide, okay? So as long as I see that attempt at swapping the ending for the second one, it's okay. So let's look at the second. We've got barium, which is in your group 2, so there's no transition metals here. It is only 2 elements, so we're going to go through the naming of first is normal, second with ide. So we get barium. And then instead of sulfur, it's going to become what? Good, John. Good, sulfide. So barium, sulfide. And that's the name of that compound. Okay? All right, let's do the next one. So Ti is titanium. If you're looking at where titanium is on the periodic table, it's here in group 4, which is a transition metal. With any transition metal, we're going to need Roman numeral in parentheses to tell someone what the charge is. So we're going to actually pause on this Roman numeral idea, and we're going to come back to it after we learn how to write our formulas. So for right now, I'm just going to put a parenthesis there. And then we talked about how oxygen becomes oxide. Okay? So titanium, right now, parentheses, we're going to come back and figure out what charge to put in there. Oxide. Okay? But we do need that parentheses there because it is a transition metal, which means we don't automatically know the charge because it can have more than one. So we're going to have to come back and clarify that. Okay? Let's do the next one. Cd is cadmium, which is here. Also, again, a transition metal. So we're going to give ourselves a spot for parentheses that we're going to come back to. And then instead of fluorine, it's going to become fluoride. So again, you're noticing that swap of the ending from fluorine to fluoride. That tells someone it's the second part of an ionic compound that's taking that charge that we know of. That fluorine in the halogen column is going to take a -1 charge. Okay? All right, now we're going to try some that have these polyatomics at play here so you can see this process. So I'm noticing for the last 3 I've got here, we've got at least 3 elements. CaSO, NiSO, CaCH, and O, so at least 3 elements. To name these, we're going to name the part that is just an element still normally, pretty much. But we're going to look at that table at the top to find the name of the polyatomic for the other part, okay? So this first one is made up of calcium and then this thing, this SO4 thing. So Ca is going to still be calcium. Calcium, there we go. I'm going to make that look a little nicer so you can read it. But we've got calcium. And then if you go up to this table, we're looking for the name of the SO4 compound. Now it has a -2 charge. So look at the top of your page. SO4 with a -2 charge is called what? What is it? Perfect, sulfate, okay? So once you find the name of it in the table, we're going to be writing in charges for all of these elements. So if you have these charges memorized, great. If you have your periodic table handy you want to grab out to use for this, that's also fine. But sodium is in the first group, which makes it have a +1 charge, okay? So +1. And then chlorine in our group 17, or halogens over here, is 1 away from having a complete shell. So remember, they take a -1 charge. So this first step, you write out symbols with their charges, okay? Notice that every single time we're doing these, we have our positively charged thing first, our negatively charged thing second. So we've got our metal first, then our non-metal. You're always writing your charges as what look like powers in math class or exponents. We call them superscripts here. And then we're going to do this thing that we call crisscrossing, where the charge for one becomes the subscript for the other, okay? When we crisscross, we don't worry about positive or negative signs anymore. We're just looking at what numbers are we bringing down. So it's going to look like this. Na is going to get the 1 from the Cl, and Cl is going to get the 1 from Na. But what I'm going to have you start doing is we're not going to carry down 1s and write them. 1s are going to be assumed, okay? But if you see it look like this without the 1s, like this instead, I need you to think that means there's 1 sodium, 1 chlorine, okay? We just don't write the 1s. It's overkill. We assume there's a 1 if there's no number, okay? Now, what if they weren't 1s, okay? What if we had something else instead? So to do another example here, so clear, this is a separate example. If we have magnesium and chlorine this time instead of sodium and chlorine, so we've got magnesium and chlorine. If we write the charges, magnesium's in your group 2, so it's +2. Chlorine is in your halogen, your -1 column. So if we crisscross then now, the 1 from the chlorine is going to come down for the magnesium, but we're not going to write that. Again, any 1 is just going to be assumed. But what does matter is we get the 2 brought down for the chlorine. Now, what this is actually telling you is 1 magnesium is needed to balance out 2 chlorines, which makes sense because magnesium has twice the charge of chlorine. So for every 1 magnesium that's going to show up, 2 chlorines have to show up to cancel out charges. Okay? Now, one last example with canceling out and reducing, just so you can see that at play here. So last example, what if we had magnesium with oxygen this time? Magnesium is +2, oxygen is -2, again, based off of the columns they're in, which we keep looking at, right? Since the first unit, we were looking at labeling these. So we crisscross. It's going to look like Mg2O2, but we always want to reduce it to the simplest ratio that we can, okay? So since it's 2 to 2, we can reduce those 2's to just say, instead of a 2 to 2 ratio, it's the same thing as a 1 to 1 ratio. So your final formula for this one would just look like this, MgO. Okay, we want to get rid of these 2's and just make it MgO with a 1 to 1 here, okay? Which makes sense because you're saying for every 1 magnesium, 1 oxygen is going to show up, which that works with the charges, they can cancel out, okay? Questions so far? We're going to do a bunch more examples, but anything you have on those 3? Okay, so let's do these examples so we can practice this a bunch. So the first one we're going to look at is lithium oxide, okay? Again, the first step is always going to be writing out your symbols with your charges, then we'll do our crisscrossing. So lithium is Li, oxygen is O. Again, you go to what columns they're in to help you find their charges. So lithium is the first column, so +1. Oxygen is your group 16, so -2. We're going to crisscross where the charge for the one becomes the subscript for the other. So we've got Li, 2O. Remember, we don't write any 1. So although the 1 from lithium came down to the oxygen, we don't write it, it's implied. So what that means is for every 1 oxygen that shows up, 2 lithiums have to show up to balance out the charges, okay? So your final formula there is Li2O. Let's try rubidium nitride. So rubidium is here in group 1, it's Rb. Nitride, remember the ending is swapped to IDE, so nitride comes from nitrogen. Rb is the first column, so +1. Nitrogen is -3 from its column. And we're going to crisscross. So it looks like Rb, 3, N. Again, the 1 from rubidium doesn't need to be written after the N, it's assumed. Okay, so for every 1 nitrogen, 3 rubidiums have to show up to cancel out the charge. Okay, so that's what this subscripts at the end tell you the ratio of them. Okay. Now let's try our first transition metal that you're seeing with these Roman numerals. So titanium as is right here in group 4. You don't know the charge of it because if you looked on your periodic table, we didn't label any charges for the middle, the transition metals, because they don't have just one fixed charge. You can't do that. That's what this Roman numeral tells you. So this is Roman numeral 3. So titanium has a +3 charge. If you didn't have this information, you would say, how would I know? Which is valid. So you know because of that 3. Okay? So titanium is Ti. We know it's +3 just because that Roman numeral 3 there. Oxide is oxygen, which has a -2 charge. We crisscross, it becomes Ti, 2O3.